Hi, my name's Alex. This is for Fluid Mechanics, and we're going to check out a YouTube manometer. This is understanding the YouTube manometer. This is how it works, and it's this simple, right? So you look at the left case, that's just pressure 1 is equal to pressure 2. There is no change in height. And then in the middle case, we can see that if we want to start from the right side, okay, so we start at pressure 2 and we go down, which means that we have to add rho GH, and then that's equal to pressure 1 on the left side. And then the third case, let's start at pressure 2, and then we go down and we follow it across to where the pressure is the same, and then we have to go up, which means we're going to subtract rho GH, and that's equal to pressure 1. And so we're going to take a simple YouTube manometer, and I'm going to look at it with water, and then I'm going to compare that to oil, and we'll see how it does and get an idea of how accurate it is. Okay, so the first thing we're going to do is take a known height in the pool, which just so happens to be this step right here. If I look at it, I've checked it out before, and it's almost exactly 50 centimeters. So now what I'm going to do is take this end of the manometer, and I'm going to put it in there, and the idea is air gets trapped in here, and then as it's trapped in here, it'll create a difference in height, and we can use that to measure the pressure. So I'm going to put it in here down to that 50 centimeters. Okay, and now when we're looking, we can see it's roughly at about 1, which is kind of perfect, and then it comes up to say 34 to 35 centimeters. All right, so I'm going to record that. Then I'm going to put oil in there, canola oil, and then we'll do the exact same thing, and we should have a smaller difference in H. Okay, so we're back, and I've filled this with canola oil, and now we're going to do the exact same thing, 50 centimeters into the pool, and then we'll take this difference in height, and then we'll compare the two. All right. That down roughly 50. So you can see this is probably about 10 at the 10 mark, but it goes all the way up to the 40. So difference of about 30 centimeters, all right, which is slightly less. So yeah, that about checks out. All right. Okay, one thing to talk about before we go is any kind of errors that we can have in this, right? Because this is definitely not going to be accurate. Okay. First off is this cup. And whether you can tell or not, it's pretty hard to get it down into the water. So, some of the air is going to get out of there, and it's just not going to create something that's super accurate, okay? Next is you can see this kink here. This happened because I left it out in my garage, and it was sitting down like this. So that's going to mess it up a little bit, right? And then, of course, there's also the tubing, where I have these that I bought at Home Depot. They're changing the diameter of the tube. So that's going to affect a little bit our measurements, right? And then also whether this is perfectly level or not, which it's not. Okay, I was going to say. So there are certain things here that are definitely going to affect the accuracy of our measurement. But you have to think about, it should still give us a decent proportion to the water versus the oil, which is what we're going to kind of look at. Okay, so let's take a look at the results. Basically, we did the third case, which was all the way on the right. And so you end up with pressure at 2 is equal to pressure 1 plus rho GH. And pressure 1 is atmosphere, so we can get rid of that. It basically becomes rho GH. You can see here we calculated it with the water. Came up with about 3,400 pascals. The oil, 2,700 pascals. And the difference between the two is about 730 pascals. So there's definitely some variation here, and I went ahead and compared that to just rho GH of the water at the 0.5 meters, the 50 centimeters. And we can see that the water gave us an answer that was almost 30% off of what we would have expected from just rho GH. And the oil was even worse at 45% of a difference, right? But you can see that they're relatively close to each other. I mean, they're not super far off from each other. And then I included here just the pressure in a bicycle tire, just to get an idea of how much pressure we're talking about, right? So this is for a road bike, and we're looking at 660 to 930 kilopascals. So it's not a lot of pressure. But it is an interesting result, and I think that, among other things, one of the main culprits, I think, is going to be the viscosity, right? Where the oil may not be able to move through that tubing quite as well as the water can. And so that's affecting the measurement. I also noticed that there was a lot of bubbles and things in the oil. So I imagine that also affected our results here. But, on a whole, if you had no other method, or if you wanted to install something that was relatively inexpensive, you could certainly make a more accurate YouTube manometer. And definitely you can buy accurate YouTube manometers, right? That might use something like mercury that's very heavy. So you can see why they're still used today, right? It's not the most accurate way to measure pressure, but if you just need a ballpark, you could certainly get there because, being 30% off for spending, $30 at Home Depot is really not that bad. So, there's my results, and I hope you enjoyed the video. Thank you.